This video is just about different ways to display data, so different ways for you to display information. So we're going to look at pictograms, bar charts, pie charts, stem and leaf diagrams, scatter graphs, and then frequency polygons and diagrams. So first of all, pictograms. This information that we're wanting to display here to do with different types of films. So comedy, thriller, romance, and it tells you which number's which. They've given you a key here as well. If you're doing your own pictogram, you need to make sure that you use a sensible key, like something that you're actually able to draw. So they've just put a wee square split up into four. It represents 4 films. So they want you first of all to complete the pictogram. So comedy is 12. So that would be 4 people there. Then another 4 people would be 8. And then another 4 people would be 12. Thriller is 6, so that would be 4 people, and then from 4 up to 6 I only want another 2, so I just need 2 of these boxes. So it doesn't matter whether you draw 2 going across or 2 going down, just so long as you've drawn half of that picture. If the full picture means 4, half the picture would be 2. And then romance is 9, so that would be 4 people, and another 4 people would be 8. And then just one wee tiny square then would bring you up to 9 people. This was for the films that were rented on Monday. Then the next bit of the question went on to films that were rented on Tuesday. And this time a wee smiley face represents 2 films. So that means comedy there were 2, 4, 6, 8, 10. Thriller there was just 2. Romance there was 2, 4, and then that wee half face would be 1, so that would bring you up to 5. And then the question says, the club manager says, looking at the total number of films rented on Monday and Tuesday, half of them were comedy. Is he correct? And you have to show you're working out. So you need to work out the total number of films rented on Monday and on Tuesday first, before you can work out if half of them are comedy. So if you go up to Monday, they said that it totaled up to 27 at the bottom of the table. So Monday totals up to 27. And then Tuesday, the 10 and the 2 and the 5 total up to 17. So all together, the total would be 27 plus 17, which would be 20, 30, 44 in total. And then the comedy. For Monday, the comedy was 12, and Tuesday, the comedy was 10. So the comedy would be 12 plus 10, 22. So looking at the total number of films rented on Monday and Tuesday, that's 44. Half of them were comedy, and comedy was 22. So is he correct? Yes. And you would say because 22 is half of 44. Just to actually give a reason why you're saying yes. Another example of pie charts then. The last question that I did, it totaled up to 72, and I had said that you should really be able to do that one without a calculator, just by working out how many 72s there are in 360, and then all of those numbers you can easily times by 5. So that question could very easily be done without a calculator. This time the table shows where 600 people go on their first date, whether they go to the cinema, they go out for food, they go for a walk or other. And these numbers total up to 600. So if you went to draw those in the pie chart, they wouldn't fit this time because they would be too big. So this time you have 2 choices. Either you need to work out 600 divided by what would get you 360. Or else you do 360 divided by 600. So 360 divided by 600 gets you 0.6, and that's what you use then as your decimal multiplier. And if you stick with that same method, then it might be easier for you to remember. So 360 divided by the total gets you your multiplier, and times them by 0.6 will actually make these smaller. So go along each of your numbers then and do 300 times by 0.6 gets you 300 times by 0.6 gets you 180. Then 150 times by 0.6 gets you 90. 100 times by 0.6 gets you 60. And 50 times by 0.6 gets you 30. The other way that you could do it is, as it said at the start there, 600 divided by 360 is 1.666, or 1 2/3. And if you divide 600 by 1 2/3, then that would get you 180 as well. But that number is a lot more awkward to work with, so I think the easiest way to do it is stick with 360 divided by your total gets you your multiplier, and then that's what you multiply by, and then these are your angles. Okay, so now we're ready to draw the pie chart. So the first one has to be an angle of 180, so that should be easy enough to do even without the protractor. You would just do a straight line from the top to the bottom, but measured anyway, so from 0 round to 180, yep. So go like that, and label that cinema, so half of the people would go to the cinema. Then the next one on the table, food, was 90. So again, you could almost do that without a protractor, because 90 would just be going straight out. But I'll measure it anyway, just to make sure I'm definitely going out the right direction. So 90 would be there. And then join that up and label that with food. And then the last two are split up into walk is 30 and other, or sorry, walk is 60 and other is 30. So the last two slices, one should be 60 degrees and one should be 30 degrees. So split that up into 60, and then you can see that you're left with 30 degrees there for the last one. So just join that up and label it walk and other. Again, make sure that you have labelled all of your slices. Alright, so what I've got now are just a few questions where the pie chart's already drawn for you, and they're just asking you some questions on it then. That's quite, well, that's okay. Right, so 120 men were asked what colour of car they own, and the pie chart shows the results. So they've got silver, white, blue, red, other. And the first question we're asked is work out the number of men who own a silver car. So the number of men who own silver, if you go to silver, it's 180 degrees, and 180 out of 360 is a half. So because silver is a half, that would be half of the people, and this question is out of 120. So the number of people, it would be half of 120, so that would be 60 people for silver then. Then the next bit, work out the number of men who own a white car. So if you compare the white car with the silver car, the white is 90 degrees and 90 is half of 180, so the white slice is half of the silver slice. So half the 60 and white would be 30. The other way that you could do it is that a 90 degree angle is a quarter of a circle, and then a quarter of 120 is 30 as well. But since we've already worked out that silver is 60, the quickest way to do it probably is just to half that to get white is 30. So do 60 divided by 2 gets you 30, or else do 120 divided by 4 gets you 30. The next one then, work out the number of men who own a blue car. So this time, again, you can just use the last slice that we found out. So white was 90 degrees and blue is 45, and 45 is half of 90. So if you half the 30 then, that would leave you with blue as 15. And that's definitely the easiest way to do that one. It would be too awkward to try to work out what fraction 45 is of 360. So it would be easier to use the 90 slice and half it. So 30 halved gets you 15 for that one. So 15 people for blue car. Then what fraction of men own a red car, and simplify your answer. So red car was 30 degrees, and that's 30 degrees out of 360. So to simplify that, first of all, I would take off those knots, and then the top and bottom there both divide by 3, so that would get you 1 out of 12. So 1/12 would be the simplified fraction. And the last one, what percentage of men have a blue car? So blue car is 45 degrees. So that's 45 degrees out of 360. And we want that as a percentage. So if you were allowed your calculator, you could just do 45 degrees divide by 360 and then times that by 100, and that will turn it into a fraction for you. So 12.5% would be the easiest way to do that one. So 12.5%. The other way that you could do it, if white, we said about 90 degrees being a quarter of the full circle and a quarter as a percentage at 25 degrees. And then we said about the 45 degrees being half of the 90. So you could half the 25%, and half of 25 is 12.5. So that's another way that you could do it. Or you could try to simplify this fraction down, maybe dividing the top and bottom by 5 or the top and bottom by 9 or something like that. Either way, as you can see, there's always different ways that you can work with these pie chart questions. So that one works out to 12.5%. One more question on pie charts, because I know it's something that people tend to struggle with. So this question, 3 singers took part in a TV contest and 3 million people voted by telephone, and then these are the telephone votes. So this pie chart then represents 3 million people. It's quite a big number we're working with here. So we're asked first of all, what fraction did each person get? So we need to go along and work out what fraction James got, Dan got and Sally got. So James is a 180 slice, and 180 out of 360 is a half. So James is 180 out of 360, and that's a half. Dan, his slice then was 60 degrees out of 360. So 60 degrees out of 360. 60 goes into 366 times, so that means that it is 1/6. Or you can take the noughts off and then divide the top and bottom by 6 if you prefer simplifying that way. And then the last one, Sally, her slice was 120 degrees. So 120 degrees out of 360. 120, 120 and 120 will get you 360. So it goes in 3 times, so that means that it's a third. Or you could take the noughts off there and then divide the top and bottom by, I was going to say 6. Divide the top and bottom by 6 would get you 2 over 6, which would then go down to 1/3. Oh, you can divide the top and bottom there by 12. I was looking at that bottom number like it was 30, not 36. So yeah, you could divide the top by 12 and then the bottom by 12 to get a third. But they would expect you to know that 180 degrees is a half, 60 degrees is a sixth, 120 degrees is a third, even really off the top of your head without having to do this simplifying. But if you don't know it off the top of your head, you are able to work it out by simplifying. Then using these fractions then, they want you to work out how many votes each person got. So out of the 3 million then, James got half of those votes. So half of 3 million would be 1.5 million, which would be 1 million and then 500,000 because he got half of the votes. So 3 million divided by 2 would get you a half. So that's that one. And then Dan was 1/6. So it would be 3 million divided by 6. So if you ignore all of those noughts there and just do 30 divided by 6, that gets you 5. And then put the 1, 2, 3, 4, 5 noughts back on again. So that would be 500,000. And then Sally was 1/3. So a third of 3 million would be 1 million. Got enough noughts there. 1, 2, 3, 4, 5, 6. So you would just do 3 divided by 3, get you 1, and then put all the noughts back on again. Okay, I was doing all of this without a calculator. You might get a question like that and be allowed a calculator, which would make it a wee bit easier for you. Okay, the next type of displaying data that I want to look at now are stem and leaf diagrams. So this is just where you are given a list of numbers and you want to just display them in a stem and leaf diagram. So the points scored by 20 teams in a competition are shown. Show this data on an ordered stem and leaf diagram and remember to complete the key. So whenever you're putting these in a stem and leaf diagram, they're generally separated into the 20s, 30s, 40s, 50s, 60s and so on. So all of the numbers in the 20s come first. So the smallest number there is 20, there's a 25, 24, 23, I don't think there's anything below 23. So stroke out the 23 and the 20 bit is already there, so you just put a 3 in there, you don't need to write down 23. And then after that there's a 24, so you put a 4 down for that one. Then there's 25 and 25, so 5 and another 5. Then the next one after that, any 26s, there's a 26, so put a 6 down. There's no 27s, so next would be 28, so you put an 8 down. So the whole point of this is that it's a shorter way of writing out the list of numbers and putting them in order, and it's shorter just because the start of the number goes in the stem and then these bits going out are the leaves. So that's all the numbers in the 20s then, so we're into the numbers in the 30s. So the smallest one in the 30s there is 30. So you put down the 0 and then the 30 bit is over there. Then there's no 31s, 32s, there's a 33 and a 33, so you write the 3 down twice. If a number appears twice, then you have to write it down twice. Then after that is 35, then 36. Oh no, there's two 35, so 35 and 35, and then 36, and then 37. So that's all the numbers in the 30s. Next would be the numbers in the 40s. So, oh no, missed one. There's a 39. This is why it's important that you stroke it out. Then the numbers in the 40s, there's a 44, then a 46, then 48 and 48, then 50 and 51. So I would always check that you have actually used all of the numbers. So yes, they're all stroked out. I'm just going to do a check. It said that there were 20, so just check 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yep, you've got them all. And then remember to complete the key. So this key, you pick any of the numbers here that you like, it doesn't matter which one. I'm just going to pick the very first one, so 23. A 2 in the stem and a 3 in the leaf represents 23 points. You need to have a key there because sometimes a 2 in the stem and a 3 in the leaf could mean something like 2.3 rather than 23. Then the question that they ask you about this then, 1/5 of the teams leave the competition and these are the teams with the fewest points. What is the lowest score of the remaining teams? So 1/5 of the teams leave the competition. So there were 20 teams. So 1/5 of the 20 teams would be, a fifth of 20 would be 20 divided by 5, so that would be 4. So that means the 4 teams with the lowest points leave the competition. So that would be 1, 2, 3, 4. Those 4 teams all go. So it says these are the teams with the lowest points, and then what is the lowest score of the remaining team? So once you get rid of those 4 teams that are leaving, then the smallest score after that then would be 26. Remember to put the stem back with the leaf again in your answer, and don't just write your answer as 6, it would be 26. So the 4th number then is the number 26, or the 4th score. Okay, so that was an example where you were having to draw out the stem and leaf diagram. The next one, the stem and leaf diagram, has been given to us. And this time it says the stem and leaf diagram shows the number of visitors to a castle over 15 days. So that's why there's 15 numbers in the stem and leaf diagram. Each number represents the number of visitors on a certain day. And it says there are 7 on the stem and 0 on the leaf represents 70 visitors. So that 0 means 60, 64, 68, 69, 70, 75 and so on. How many days had more than 80 visitors? So that would be 81, 82, 83, 92 and 94. So those numbers there. So that's 1, 2, 3, 4, 5 days had more than 80 visitors. The next bit of the question, work out the range. The range is the biggest, take away the smallest. So the biggest amount of visitors was 94. And then take away the smallest amount of visitors is 60. So 94 take away 60 leaves you with 34. And the last question, work out the median number of visitors. The median is the middle number whenever they've been put in order. They are already in order up here, so you could just go and stroke them out from this stem and leaf diagram by stroking out one from the start and one from the end. One from the start and one from the end. Then match that one with that one, that with that one with that one, then start and end, and I'm left with that one. So I'm just going to check that I've got the same amount before and after. So 1, 2, 3, 4, 5, 6, 7 before, and 1, 2, 3, 4, 5, 6, 7 afterwards. So I would always check, if you're stroking out from the stem and leaf diagram like that, check that you've got the same amount either side of the median. So that 6 isn't just a 6 on its own, it needs to go with the 7 over here to be 76. So your answer for the median is 76. So I did that from stroking out in the stem and leaf diagram. Sometimes people do this and they make a mistake, either with their stroking out or they forget to put the 7 back with the 6 again. So in the exam, if you've got enough time, I would take the numbers out of the stem and leaf diagram, write them in a big long list going across your page, and then just go in like that until you get the one that's in the middle. It might take you a wee bit longer, but this is worth maybe 1 or 2 marks, and you need all the marks you can get. Okay, that's stem and leaf diagrams then. The next one I want to look at are scatter graphs. So scatter graphs, they're called scatter graphs because the points are all scattered over the grid. And you plot the points with a cross. Sometimes there's a pattern to them, sometimes there's not. If there's a pattern to them, then the fancy name for that pattern is correlation. If your crosses are all going up the page, then that's said to have positive correlation. If they're all gradually going down the page, then that's said to have negative correlation. And if they're all scattered all over the place, then that means that there's no correlation. This line that I've drawn in here is called your line of best fit. So you don't actually join them all up one by one, otherwise you would end up with a really higgledy-piggledy line. What you do is just do a best fit line or trend line through them. And then that will also help you decide what type of correlation there is. And you can also use this trend line or the best fit line to do estimations. You'll see that in a wee minute when we come to a question. So the first question then is just matching the picture with the type of correlation. So match each scatter graph with a description, and the first one has been done for you. So then match this one here up with strong negative correlation. So strong because all the crosses would be close if you drew in the best fit line there. Your ruler. So the best fit line would be something like that. And all of those crosses are very close to the best fit line, so it's strong. And also because it's going down as you go across from left to right, it's going down, so that's negative correlation. This next graph, if you were to draw in your best fit line, it's going up, which means it's positive. And again, all of the crosses there are very, very close to that line. So I would say that that is strong positive correlation. The last graph then, those points are so scattered all over the place that there's no way that you could draw in any best fit line there at all. So that would be either little or no correlation. So if you can't draw in a best fit line, then that means that there's no correlation or there's no connection between whatever the two things are on the graph. So, question then. Scatter graph shows the lengths and widths of 20 birds' eggs. So this is shown on this graph. And the question that we're asked then, one of the eggs has a length of 52 millimeters. What is its width? So if you go to a length of 52, and we want to know what the width is. So one of the eggs has a length of 52, so go to length, go to 50, and then 52 would be one wee square after that, and then rule up and over. So the egg that had a length of 50 had a width of 40. I haven't drawn in a best fit line or anything there because they're not asking me to do any sort of estimation. They're just wanting me to pick out the width of that actual egg. So that would be 40 millimeters. Part B says all the points except one show strong correlation. Circle a point that does not fit this pattern. So that would be this one, which is way up out on its own. So that one doesn't follow the general pattern. That egg does not fall into the same sort of pattern as these other ones. Then part C, what type of correlation does this graph show? So if I go back here and try to draw in a best fit line, I would normally do it just to make sure that it's definitely going at the right angle, because you might think, oh, it could go like that, it could go like that. All of those look like they're kind of in the middle of all of the crosses. So if you do a sausage shape, which people normally find very amusing, do a sausage shape and then slice it in half long ways. I've ignored this one because it was way out on its own, and I've ignored that one because it was way out on its own. So just draw the sausage shape around most of your crosses. They very rarely give you ones like this in the exam actually that are way out on its own. Normally you would do the sausage shape around all of them and then slice that in half. Something about this best fit line, you don't have to go through the first cross and the last cross, and you don't have to go through naught, and you can actually extend it on out beyond the sausage shape. So I'll just do that now in case they ask me about something further on out. Okay, so that's your general trend or your best fit line. Then part D, use the graph to estimate the length of an egg with a width of 30. So they're wanting me to estimate the length of an egg with a width of 40. So if you go to a width of 30, if you go to a width of 30, the reason this is going to be an estimate is because there were no eggs that had a width of 30. So we're going to be guessing if there was one with a width of 30, roughly what would their length be. So go across to your best fit line, not to the sausage shape, you go to the best fit line and then down and read off your result. So that would be 42. So 42 millimeters would be the length of the egg whenever the width is 30. Sometimes they get you to plot the scatter graph, so that's just a case of you plotting coordinates, and just be careful that you're reading the scale properly. But most of the time they get you to plot it, then do your best fit line, so sausage shape best fit line. They ask you for the correlation, so that's either positive, negative or none. Just realised I didn't actually answer the question of what type of correlation it was. It was positive correlation. I went and did the best fit line and then forgot about that. So positive correlation, draw in your best fit line and make the best fit line, use it to be able to do your estimates. Okay, the next type of displaying data then are frequency diagrams and polygons, and I've just got one of each of these. I'm going to try to raise the camera up a wee bit here, see if this makes it any. Yeah, I'll fit a wee bit more in there. So frequency, polygons and diagrams. So the table shows information about the amount of money people spent at a market. Draw a frequency polygon to show this information. So it's very easy for you to get these two graphs mixed up because they've both got the word frequency in it. So a polygon is a straight line graph and you plot them at the midpoint of these groups. And then a diagram, a frequency diagram, is just a bit like a bar chart, and all the bars this time are stuck together and there's no gap in between them. So a polygon is a line graph, and then a frequency diagram would be a bar graph. So this one is a frequency polygon. So I'm going to plot a line graph at the midpoint of each group. So the midpoint between 0 and 10 would be 5. So I'm going to go across to 5 and up to 40. So across to 5, I'm going to use this to make sure I'm going up the right line. So across to 5 and up to 40 would be the first point, and just plot them with a cross. And then the next point would be the middle between 10 and 20 would be 15 and up to 70. So go across to 15 and up to 70. The next point between 20 and 30 would be 25 and up to 86. So 25 and follow that line up to 8246. Next one, plot at 35 and up to 78. So 35 and up to 72468. And then the last point between 40 and 50 would be 45 and up to 54. So 45 and up to 52, 53. 4. Okay, after that then you just join them up to make a straight line graph. You don't use a best fit line or anything like that, that's just for scatter graphs. So these ones you actually join the points up. So go up, and up again, and then down, and then down. That's it, that's a frequency polygon. So it's just a line graph plotted at the midpoint of these groups. The same way as you use the midpoint for finding the mean from a frequency table, you use the midpoints here to plot your graph. Then they've asked you a question to go with it. What fraction of people spent more than £30? So if you go back up to the table, these people here only spent between 0 and £10. These ones spent between 10 and 20. These people between 20 and 30. These ones between 30 and 40. And then these last ones are between 40 and 50. So spent more than £30. So that would be just these last two groups in the table, not these 86 because these were between 20 and 30. They didn't go over £30. So if you add up them, the 78 and the 54, that will tell you how many people in total spent over the £30. So that gets you 132. But they want that as a fraction out of the total. So you would need to total all of that up. So 40 plus 70 plus 86 plus 78 plus 54. So that totals up to 328 then. So as a fraction that would be 132 out of 328. So 132 out of 328. It didn't say for you to simplify it, but you can simplify it on your calculator. So that's 132 over 328. Doesn't simplify down very much really. So 33 out of 82. If it doesn't ask you to simplify, I would maybe just leave it in case you simplify and then mess it up and get the wrong answer. One more then. This is a frequency diagram this time. So the masses of 100 bags of sprouts are summarised in the table. So these are the masses and then these are the frequency of how many bags of sprouts there actually were. Show the data on a frequency diagram. So diagram this time, not polygon, so it's not a line graph, it's a bar graph. So the first bar goes between 600 and 800 and do it up to a height of 10. So go between 600 and 800 and up to 10. So between 600 and 800 and up to a height of 10. Okay, you can see here whenever I'm doing this that the bars aren't showing up very well, so if it happens like that for you in the exam, just shade them in a wee bit so you can see them a bit better. Then the next one is between 800 and 1000, and we want to go up to 46 this time. So between 800 and 1000 and right the way up to 45, 46. And that was 1000 it was going up to, so over to there. Joined up and shaded in. The next one then is going between 1000 and 1200 and up to 32. So we've already got that line in, so 1200 here and then up to 30, 31, 32. And then over, shaded in. And the last bar between 1200 and 1400 and up to 12. So just up to, where's 10, 11, 12, so up to there. And then over, and then shaded in. Okay, I don't know why those squares have gone so bad looking on this video at all. But anyway, what percentage of bags had a mass below 800 grams? So what percentage below 800 grams? So if you go up to the table, below 800, there's only those first 10, because these next 46 are above 800. So the ones below 800 are 10, and that's out of 100. So that should be an easy percentage. 10, and it's already out of 100, so that would be 10% of the bags had a mass below 800. Okay, so that's the end of that video. Quite a lot of information there. So that's the end of that one.